everybody and welcome to this video. In this video, we're having a look at the Gauteng Department of Education preliminary paper for 2020. We are having a look at question 2. The intention for this video is for you to pause and attempt the questions by yourself and use the video to mark your solutions or if you are stuck. If you are having any problems with the section, first watch the series on number patterns before attempting past paper questions. If you have found out that you have not understood a section, please go back and review the sequences and series playlist so that you can catch up. Okay, so let us have a look at this question. So it says you are given the following quadratic sequence, and it says write down the value of x in the sequence. So we have to write down the next term. So we have what we're going to first look at is perhaps the type of pattern it is. So let us have a look at the differences to determine what type of pattern it is. So 7 minus 1 is 6, 15 minus 7 is 8, 25 minus 15 is 10, so it doesn't have a common first difference, so we know it's not linear, but it has a common second difference, so we know that we are dealing with a quadratic pattern. So the next thing is we add 2, which means we're adding 12 to get x. So therefore, x is 25 plus 12, which is 37. 2.1.2 says calculate the expression of the nth term. So to calculate the nth term, knowing that it is quadratic, we know that it follows the formula an squared plus bn plus c. So we would like to find out what's a, b, and c. To find out what's a, we equate 2a to the second difference. So what we get is 2a is equal to 2, and we have that a is equal to 1. To get b, we use the equation 3a plus b is equal to the first difference, which is 6. So then we have 3 times 1, because that's what we have a is, plus b is 6. So here we have b is 3. And finally, to get c, we have a plus b plus c is equal to our first term. So 1 plus 3 plus c is equal to 1. So finally, we get that c is equal to minus 3. Therefore, the expression for the nth term by substituting that in is Tn is equal to n squared plus 3n minus 3. Okay, let us have a look at the next question. 2.1.3 says Wn represents the general term for the first differences. Determine the nth term of the quadratic sequence if Wn is equal to 50. So we would like to find, so let us first make a get Wn. So Wn is the pattern for the first differences, which you can see is a linear pattern. So we're going to have 1 plus a times n minus 1 times d. For the first differences, the first term is 6, and the common difference is 2. So the formula or the rule that Wn follows is 6 plus 2n minus 2, so we distribute, which is 4 plus 2n. So that is the general term for Wn. We would like to know at which term do we have Wn being equal to 50. So we want to solve for n when Wn is equal to 50 as indicated over here. So let us go ahead and calculate that. So we have that 4 plus 2n is equal to 50. So 2n is equal to 46. So that means n is equal to 23. So it's the 23rd term that has that. So then we want to calculate T23 from the quadratic pattern using the formula that we have got from the previous question. So we have that it is 23 squared plus 3 times 23 minus 3, and typing that into your calculator, we get that it is 595. Okay, let us have a look at the next question. So it says, consider the following pattern. So it has 0, a half, 0, a half, 0, 3 halves, 0, 5 halves, and so on and so forth. So then it says, assume that the pattern continues consistently. Write down the term of the 191st term. Now, what we notice is that every odd term is zeros, the first, the third, the fifth, the seventh. So if it continues in this pattern, every odd term will be 0, including the 191st term. Then we have 2.2.2. It says determine the sum of the first 500 terms. So for the 500 terms, we have 500 zeros, and then we have 500 terms from this other pattern. So we have we have 250 zeros, and we have 250 of the term of the pattern minus a half, 3 halves, 5 halves, and so on. So we would like to calculate the sum of 250 zeros is 0, and then we would also like to calculate the sum of these 250 terms. So for this term, the common difference is 1. Each time we are adding 1. And then this is an arithmetic pattern then. So we're going to use the arithmetic formula to calculate the sum of these 250 terms. So the formula is n over 2 times 2a plus n minus 1 times b. Okay, so our n is 250. We want the first 250 terms. And our first term is minus a half plus 250 minus 1. And our difference is 1. Typing that into our calculator, we get that the 251st terms, the sum of it is 31,000. Therefore, the sum of the 500 terms is 500, 250 zeros, which is 0 plus 31,500. 310. So that is 310. Sorry, too many zeros. Okay. Let us move on to the last question. So it says, consider the following geometric sequence, and we have this pattern, and it says determine the value of k. So let us start. So this here is missing a part. So if it is a converging, so we want to know for a converging pattern. It's missing that it's a converging pattern, and want to determine the possible values of k. Sorry, a piece of the question has been removed. Okay. Okay, so it's a converging pattern. That was missing from the question. So if it's a converging pattern, we know our radius, our ratio. So for 2.3, we know that our ratio should be between minus 1 and 1 for converging series. Okay, so our ratio is, if we divide two terms, so let's say it's calculated, our common ratio is T2 divided by T1, for example. So T2 is 8 times 1 minus k, 8 times 1 minus k to the power of 5, over 5 to the power of 2, over 4 times 1 minus k over 5. So if we simplify that, we get that the common ratio is 2 times 1 minus k over 5. So that is our common ratio. So let's replace it in this inequality. Okay, and then we're going to make k the subject. So let's first multiply both sides by 5. And then divide both sides by 2. And then we're going to subtract 1 from both sides. So 7 over 2 minus k, 3 over 2. And then finally, we're going to divide by a negative. But when we divide by a negative, the sign of the inequality swaps around. So we have 7 over 2 is greater than k, which is greater than minus 3 over 2. And that is then our solution. Okay. So I hope that you have got a lot of these answers correct. If you did not, please go and review our playlist on sequences and series. Thank you for watching, and please stay tuned for the rest of the paper. Bye.